So, NVIDIA just announced something that might genuinely be the blueprint for the next everything in the digital economy. It's called Ising, and it's a new family of AI models designed to be the operating system for quantum computers. Okay, we've got to dive into this, because this isn't just some minor upgrade. It's a completely different way of thinking about computation itself.
It all really starts with a question that's been bugging the entire tech world for years now. We've all heard the hype, right? We've seen the wild lab experiments. So why aren't these incredible machines actually running in our data centers, solving real problems for us today?
Well, it's because there's this huge, massive gap between the promise and the reality. The promise is, it's unbelievable, solving problems that are basically impossible for us right now. But the reality? Well, the reality is that the building blocks of these computers, the qubits, are just absurdly fragile. They are so sensitive that even the tiniest bit of noise can completely wreck a calculation. The analogy here is perfect. They are literally like soap bubbles. Incredibly powerful for a split second, but then pop.
And this fragility, it really boils down to two enormous engineering problems that have been holding back this entire quantum revolution. So let's break them down.
Okay, so problem number one, as we just said, is that qubits are just fragile. Any little bit of noise from the environment, and boom, you get errors. Problem number two is the calibration. It's almost impossible. To get a quantum processor ready to go, you have to perfectly tune thousands of different parameters. The source material had a great way of putting it. Imagine asking a team of brilliant physicists to perfectly tune millions of guitar strings all at the same time. It's not just difficult, it's basically impossible to do at scale.
And just to put the scale of this challenge into perspective, right now, the very best quantum hardware makes about 1 error in every 1,000 operations, which, sounds pretty good. But to actually be useful for solving real business problems, we need to get that error rate down to 1 in a trillion. That leap is just staggering.
And this is where NVIDIA's new strategy just changes the whole game. They've built what is essentially an AI operating system, this Ising model family, and it's designed to be the control plane that can finally tame these wild quantum processors.
So the first part of this new OS tackles that impossible calibration problem we talked about. It's called Ising calibration, and you can think of it as a kind of AI physicist. It's a huge 35 billion parameter model that can literally look at the data coming off a quantum chip and figure out how to tune it perfectly, all on its own. It takes a job that took a team of humans days, and it cuts it down to just a few hours.
And get this is not just any old AI. What's so interesting here is the actual data. On the standard industry benchmark, this specialized AI physicist blows away even the most advanced general-purpose AIs. Look at this. It scores almost 15% better than GPT 5.4. This just proves that for these super complex scientific jobs, you need a specialized model. It's absolutely crucial.
Okay, so the AI physicist gets the whole system tuned up and ready to go. But what about errors that happen during a calculation? Well, that brings us to the second part of the OS, Ising decoding. It's built on this really cool concept from physics called the Ising Hamiltonian. It's basically a mathematical trick to model the energy of a system. And in this case, NVIDIA is using it to find the most likely error that just happened inside the quantum computer.
And the AI models they've built on this idea are just stunningly good. You can see it right here. These Ising decoder models find and correct errors in real time. Compared to the standard way of doing things, the fast variant is 2.5 times faster, and it's even more accurate. And if you need even more precision, the accurate variant is still over twice as fast and a whopping 50% more accurate. That speed is everything.
Now, why is that speed so unbelievably important? Because you have to catch and fix an error before another one has a chance to happen. And that means you need a crazy fast connection between the quantum chip and the AI running on the GPU. NVIDIA solved this with their NVQLink interconnect. It gets the round-trip time down to less than 4 microseconds. That's the physical piece of the puzzle that makes real-time AI-powered error correction even possible.
Okay, so the tech is absolutely incredible. We get it. But the real story here is how this finally moves quantum computing out of the science lab and into a tool that can solve actual high-value business problems. So let's look at a couple of examples.
In finance, the impact is going to be immediate. We are talking about being able to analyze market risk not overnight, but in real time, like right in the middle of a market shock. And for high-frequency trading, this system can spot profitable trades at the microsecond level, trades that are just completely invisible to slower classical computers.
Then you've got healthcare.
This could unlock what the source material calls a proteome-scale revolution. Think about it. NVIDIA's BioNeMo platform can already predict how proteins fold. Now, you add a reliable quantum computer to that, and researchers can actually simulate the quantum interactions between atoms when a drug connects to a protein. This could just dramatically shorten the path from a discovery in a lab to a life-saving treatment.
And for global logistics, this is a total game changer. The best solvers we have today, even NVIDIA's own QOpt, are great at finding the best route if nothing changes. But a hybrid quantum system can handle what's called stochastic optimization, problems where all the variables, like weather, traffic, port delays, are constantly changing. This is how you finally solve the trillion-variable problem that is the global supply chain.
All right, now here's where the story gets even bigger, because NVIDIA made this huge strategic move. They released the entire Ising model family as open source. And this connects directly to one of the most important geopolitical trends happening right now, the rise of sovereign AI.
So what exactly is sovereign AI? It's pretty simple, really. It's the idea that for a nation, the ability to build and control its own AI is a strategic asset. It's just as important as energy independence or food security. It's about a country's digital self-determination.
And we are seeing countries all over the world racing to build this capability. I mean, look at Kazakhstan. Their generative nation strategy is incredibly ambitious. They're building these massive supercomputing clusters. They've already trained 1 million people in AI, and they're seeing this huge explosion in startup investment. Or take a look at Serbia. They're aggressively upgrading their national supercomputing platform. And that plan to deploy 640 Grace Hopper superchips, that's really significant. That's the exact kind of hardware that is perfectly designed to handle this new world of hybrid quantum classical computing.
And then you have Ukraine, which is pursuing what they call an agentic state, using AI agents to power things like government services. But crucially, they're building your own language models trained on their unique cultural data, and they're using AI to innovate like crazy in their defense industry. For all these countries, having powerful, open-source tools like Ising is just vital.
Okay, so this all brings us to the final piece of the puzzle, NVIDIA's absolutely brilliant business strategy here, which is basically rewriting the rules of the entire computing industry.
See, the old way to get into this market was to try and build the quantum computer itself, the engine, but everybody's trying to do that. NVIDIA took a completely different path. They're selling the picks and shovels for the gold rush. They built the AI control system, the operating system that can run on everyone's quantum computer, no matter who actually builds the best hardware in the end.
And the prize for winning this race is just enormous. The global quantum computing market is projected to be worth over $11 billion by 2030. And by creating the essential software layer that the entire industry is going to depend on, NVIDIA has positioned itself to capture a huge, huge slice of that pie. So this all brings us to one final fascinating question. NVIDIA has delivered the OS. They've delivered the thing that makes quantum computers stable and usable. It's basically the Microsoft DOS or the Windows for this brand new quantum era. But if AI is the operating system, what's going to be the killer app? What's going to be the VisiCalc or the web browser of the quantum age that changes everything? That's the next chapter, and it's really just beginning to be written.